Hello everyone, I am Sayan Dutta and I am presenting before you the assignment 5 of mechanism sessional windscreen wiper mechanism. Here is our names of our team members Samares Malik, Gourab Pal and Sayan Dutta. So let us discuss about the problem statement. As displayed, the problem statement says us to synthesize and make a uh, simulator for the windscreen wiper mechanism with no quick return effect. In the simulation, we have to mark the area wiped, and also we have to show the simulation and Python to show other plots and calculations. We also have to highlight the synthesis process and simulation approach and working of the simulator. Moving forward, let us discuss about what is a wiper basically. So a wiper is generally consists of a metal arm. One end of it is pivoted and the other end has a long rubber blade attached to it. The arm is powered by a motor and often an electric motor, and the blade is swung back and forth over the glasses, pushing water and other particles to improve the visibility of the glass of the surface on which it is used. So moving forward, let us describe about how a wiper works. So the wiper sweeps out an angle of roughly 45 degrees. Throughout the wiper's motions, torsion springs push the wiper's blades into the windshield, causing the blades to slide across the windshield. And the wiper is completely bounded by the crank element and primary transmission or parallelogram mechanism for the working, which works by transmitting the power from an electric motor to the roots of the wiper arms, converting rotary motion into back and forth motion. The mechanism is based on 4-bar kinematic linkage, where two of the linkages are attached to ground. Here the ground is the car body, and so let's move forward, and from now on my friend Samresh will carry with the proceedings.
Hello everyone, my name is Samares Malik. I am going to show you the simulation in AutoCAD. We have prepared it in 2D plane, and as you can see, we have showed the links, and the links are accordingly set with no return effect, no quick return effect. And we have used the AutoCAD constraint here, like we can go to the drafting and we can show that parametric modeling. Using parametric modeling in AutoCAD, we have synthesized this model, and we have just uh, to show the revolute joint, we have made coincident of the endpoints of two linkage. This is how we showed the mechanism. And here is the actuator link. As you can see, here is the actuator link, and this will rotate with uniform velocity, and this will result in the to and fro motion of the wiper. And let us show you. Let us select the actuator. As you can see that it is rotating and the wiper is moving to and fro, and we are getting a wipe area. And we can improve this upon by changing the actuator link, and this will result in the larger wiper area. And let us stop it, and now I am going to show you the equation that we have used for displacement analysis and velocity analysis. Here we have used analytical method to find the displacement analysis, that is the relationship between the theta 2 angle and theta 4 angle. Here theta 2 is the input angle given by the actuator, and theta 4 is the wiper angle that we are seeing in the windscreen. And after simplifying this equation, we are getting this kind of equation, and from this we can get the theta 4 as this, where a, b, c are the corresponding constants here. And from here we can also calculate the value of theta 3, which will be used for the calculation of velocity of theta 4, angular velocity of theta 4. And for the velocity also, we have differentiated the displacement relations and got the relationship between theta 4 dot and theta 2 dot. let us show the Python code. Here we have coded the uh, coded the mechanism to get the displacement and velocity of link 4. As you can see here, we have calculated accordingly and got the value of theta 4 maximum and theta 4 minimum, and we are using this to plot the variation of theta 4, that is the output angle, with the actuator angle, that is the input angle, and this shows the variation, this plot. The y-axis is the theta 4 and the x-axis is the theta 2. And this with the same calculation we have used the variation of theta 4 dot, that is the velocity of the wiper, with the location of the actuator. For example, the theta 4 dot or the omega 4 is varying accordingly with the variation in theta 2, that is the actuator angle, and we have kept constant of the actuator speed, and for example we have taken it as 1, and then we have plotted this. And here, as you can see, with respect to the maximum angular velocity of theta 4, the curve is symmetric about the maximum value, which means the velocity of return stroke and the velocity of forward stroke is almost identical, and that's so that it is a mechanism synthesized with no quick return effect. Um, and here you can see that the link 4 is the wiper, and that's explain the mechanism. Now my teammate Gourab Pal will take on from here and show you the other wiped area and other things.
Hello everyone, my name is Gourab Pal. I am going to explain the Python code for the assignment windscreen wiper mechanism sessional assignment 5. So for the code implementation, we have imported some dependencies like IPython, NumPy, matplotlib and all, and then we have taken the length of the links of the wiper mechanism, like x0, y0, l1, l2. These are the links, and we have initialized the angles between the links, and then we have calculated the minimum angle and maximum angle the wiper mechanism while performing the process. And then we have used this code to show the animation, the how the windscreen wiper mechanism works, and how much area it sweeps in this procedure. And so this is the animation. It shows the area, and we have also calculated the area. Here it is 66,831 millimeter square. So that's all. Thank you.